All right, if it all went well, the fastest object ever built is zooming in extremely close to the sun. We're talking about the Parker Solar Probe. It's cruising about 3.8 million miles from the sun, the closest a man-made object has ever gotten. The probe will get pretty hot, but has been built to withstand temperatures at that distance, of course, we hope. Let's get some perspective on this historic flyby. We're joined by former astronaut Leroy Chiao. Great to see you, sir. Very exciting times. It's historic. I think probably one of the most historic missions for NASA. What answers are scientists hoping to get?
Well, as you know, the sun is a very turbulent body. It looks, like a big point of light to us here on Earth, but there are a lot of sunspots going on, a lot of activity, and there's something called a solar max and a solar min. It's about an 11-year cycle. Parker was launched in 2018, kind of right in the middle, and so it saw the transition from a solar minimum to now the solar maximum, which occurred just 2 months ago. And so it's going to come the closest any probe has to the surface of the sun. As you pointed out, about 3.8 million miles. It sounds like it's pretty far, but in perspective, if the distance from the Earth to the sun were a football field, you'd be inside the 5-yard line, right? So it's going to be, we're hoping, NASA scientists are hoping that there will actually be a solar flare during its fly through, and so we can observe it up close and look at up close at the sunspots and other activities and help to better understand the dynamics of the sun.
Absolutely. I mean, one question, I guess, eluding scientists for quite some time, is how the surface temperature differs so dramatically from the center of the sun, the corona. Do you think we'll get details on that as well? Because I think, it's one of those big burning questions, if I could say, that hasn't really been answered since we've been studying the sun.
Right, and so the sun is, there are many different regions of the sun. The corona, as you mentioned, it's a little bit not intuitive, but it can actually get cooler if you get to one of the inner, more inner regions. So a spacecraft is able to stand 200 degrees Fahrenheit, which is not a lot when you consider how hot the sun is. But it's because we understand enough about the physics of the sun that we can actually design the profile so that it doesn't get damaged by the heat.
In terms of the technology that needed to be developed to make this happen, obviously years in the making, this solar probe can handle extreme temperatures. It's moving so fast. I mean, the numbers are extraordinary in terms of the speed at which it's traveled. Tell us about what it took to create this probe.
Sure. So it's an evolution of, all the experience that we've had in the past of making probes and other spacecraft. And so, as you pointed out, 430,000 miles an hour, that's the fastest probe that we've ever created, humankind. And so it's breaking some records there for sure. Also, 2,500 degrees Fahrenheit. Again, it doesn't sound like much compared to what the sun's actual temperature is, but, that's a big number. That's almost the same number of degrees that we experience on spacecraft re-entering the Earth's atmosphere. We can get up to 2,500, 3,000 degrees Fahrenheit.
I want to talk about this magnetic fluid that washes over our solar system. And I think this is one of the interesting things that perhaps we'll get insight into, and also how it affects planet Earth. What do you make of the headway and a lot of the research that's gone into understanding this magnetic field?
Right. So the Earth is covered in a magnetosphere. That is, our magnetic fields, the Van Allen radiation belts and all that, protect us from most of the sun's radiation, the charged particles coming from the sun. Without that magnetosphere, life on the Earth would not be possible. And so what we see during solar max and solar min are variations in the shape of the magnetosphere. And counterintuitively, at solar max, the magnetosphere is such that actually deflects more particles away from the Earth than at solar minimum, right? So a little bit counterintuitive, but it helps us understand those things. And the whole field of study is called space weather, not weather as we know it here on the Earth, but how do these different magnetic fields and fluctuations in the sun, how that affects us here on the Earth.
Okay, so always with space exploration and probes like this, on its path, it delivered unplanned images, surprising, beautiful as well. I want to show you this image of Venus that was taken, and I also understand that it's a discovery of dust streams within Mercury's orbit as well. So much money and effort has gone into this, but I think give us an understanding of missions like this and what they entail and what they mean for overall space exploration and understanding, Leroy. Leroy, can you hear me? Yeah? All right. Leroy Chiao there for us. We just lost him, but really fascinating, historic mission there by NASA.